Welcome you all for the video lecture on fluid mechanics and machinery. In this video lecture we are going to see about module 1 fluid properties. Myself K. Davasalingam, Assistant Professor Mechanical. We start with Tirkural Neerendru Amayadu Ulagu by Thiruvalluvar. That means when water fails, function of nature come to an end. Likewise, fluid mechanics is the base for engineering. This is the overview. In this video we are going to start with Module 1. These are the contents for Module 1. In this, up to buoyancy force is part 1 and below 1 is part 2. These are the physics of fluid mechanics. They are all the scientists who developed the fluid mechanics in various decades. We visit them and start the fluid mechanics. Before going to start the fluid properties, we are going to understand the relationship between bullet train and kingfish. Here, that bullet train is traveling to the tunnel. In Japan, they have these very fast bullet trains. They were getting so fast that the typical bullet shape. The shape was causing a loud booming sound when the train would exit and enter the typical train tunnels. And the reason this booming was happening that this cushion of air was building up in front of the speeding train. It's going like 300 kilometers per hour. An engineer had witnessed a kingfisher bird diving down through the air, going into the water and creating very little splash. By this principle, they are changing the shape of the bullet train. Finally, the new model bullet train, it moved through tunnels without creating the boom, and it saved 10 to 15% more energy because of this effect. The view on fluid properties. Fluid can flow from place to place and their density can change if they are compressible. For example, gases. Fluids are pushed around by pressure forces and an object immersed in a fluid experiences buoyancy. Next one is fluid definition. A fluid is any substance which can flow. Example, liquids and gases. Fluid statics. It is a study of fluid in equilibrium. We are going to deal the properties of density and pressure. Look at the figure. It is in the equilibrium condition. If the fluid in motion, we call it as fluid dynamics. There are two kinds of fluid in motion. One is kinematics and dynamics. Kinematics is without considering forces. Dynamics is with considering forces. Look at the image. It's the Google map view of Chennai city. It is high denser city. Why we call it as high denser city? Because it has high population in definite space. So we can compare with solids because solid has very tightly packed molecules. Look at the image. It is a small town in Tamil Nadu. In here, the medium of population in definite space. We can compare with liquid. Look at this figure. This is a view on Western Ghats. In here, very less population in definite space. We can compare this as gas. So we are going to compare the density. In gases like hydrogen, oxygen and carbon dioxide having less density, the unit is kilogram per meter cube. In liquid, alcohol, water, mercury, yes, medium level of density. In solid, aluminum, steel and uranium having high density. At standard temperature and pressure, the tube has various liquids at different densities. In here, honey has high density, so white at bottom. Edible oil has less density, so white placed at top. Next we are deal with basic fluid properties. The first one is density or mass density. The notation is rho. The density is defined as a fluid is the concentration of mass per unit volume. The formula of density is mass by volume. We can say it as rho equal to m by v. The unit is kilogram per meter cube. For example, the glass has unit volume in meter cube and it has certain amount of mass of water molecule in kg. Look at the glass. In here, the object is dipped or submerged in water. If the object is having high density, it will be dipped into the water. If it has less density, it will be at the top and it floats. These are the important unit conversion. A mass 1000 gram is equal to 1 kg. Volume 1 millimeter cube is equal to 10 power minus 3 centimeter cube. That is equal to 10 power minus 9 meter cube. Volume 1 liter equal to 10 power minus 3 or 1 divided by 1000 meter cube. Density is equal to 1 gram of centimeter cube is equal to 1000 kg per meter. Here we are going to compare density and weight density and understand what is weight density. We had seen density rho equal to mass by volume. The unit is kilogram per meter cube. Then weight density, also called as specific weight, the weight of a unit volume of a substance, omega or gamma, that is equal to rho g. The unit is Newton per meter cube. So we come to know mass density means mass by volume, weight density means weight by volume. Here omega equal to weight of the fluid divided by volume of the fluid. So mass of the fluid into acceleration divided by volume of the fluid. Here weight is mass into acceleration. So omega equal to mass of the fluid into gravity divided by volume of the fluid. Next one is density depends upon molecular mass and intermolecular forces. For example, hydrogen bonds, temperature and pressure. We are going to compare density with pressure and temperature. If we increase the pressure, the density increases. If we increase the temperature, the density decreases. And specific weight is also depends upon gravitational force, that is G. Next we are see about specific volume and specific gravity. Specific volume. Generally density is mass per unit volume. Then what is specific volume? Volume per unit mass. That means reciprocal of mass density. Specific volume nu is equal to volume by mass, that is equal to 1 by rho, reciprocal of density. Here we have an example of volume equal to 12 meter cube and mass is 3 kg. So we find out density is equal to mass by volume 0.25 kilogram per meter cube, and specific volume is reciprocal of density, so 1 by rho, that is equal to 4 meter cube per kg. The next one is specific gravity. The ratio of the density of a substance to the density of standard substance at a specific temperature, generally 4 degrees Celsius. The standard liquid is water. Specific gravity is equal to rho by rho of water. Generally, weight density of liquid divided by weight density of water. Here we can replace weight density is equal to mass density. We can say mass density of liquid divided by mass density of water. Both are applicable. Both weight density divided by weight density and mass density of any liquid divided by standard liquid. Thus, weight density of liquid is equal to S, that means specific gravity into weight density of water. We can also find out the density of liquid, that is equal to specific gravity into density of water, 1000 kg per meter cube. So we can find out density of any liquid with the specific gravity and density of water. Here we can conclude S less than 1 if the fluid is lighter than water, example milk. If the specific gravity is greater than 1, the fluid is heavier than water, example mercury. These are all the formula for basic properties of fluids. Here the mass density is equal to mass of the fluid divided by volume of the fluid, that is rho kilogram per meter cube. Here the specific weight or weight density omega equal to weight of the fluid divided by volume of the fluid. The unit is Newton per meter cube. Here the omega equal to rho g, that is called as specific weight or weight density. Next, specific volume. Volume of the fluid divided by mass of the fluid, that is equal to reciprocal of density. Next one is specific gravity. For liquids, weight density of the liquid divided by weight density of water, that is water is standard liquid. It's also defined as mass density of liquid divided by mass density of water. For gas, weight density of gas divided by weight density of air. It is also denoted as mass density of gas divided by mass density of gas. It will be useful to solve the problems. Next we are going to see few problems. Next we are going to see problem 1.1. It will be 2 marks. Calculate the specific weight, density and specific gravity of 1 liter of liquid which weighs 7 Newton. We have to calculate specific weight, mass density, specific gravity of 1 liter of liquid which weighs 7 Newton. First we write the given data. Volume 1 liter equal to 1 divided by 1000 meter cube or 10 power minus 3 meter cube, and weight is 7 Newton. First we are going to find out specific weight or weight density omega. The formula is weight of the fluid divided by volume of the fluid. Weight of the fluid is given as 7 Newton. Volume is, just now we convert liter to meter cube, 1 divided by 1000. That will become as 7000 Newton per meter cube. Next we are going to find out mass density. Here the specific weight is omega equal to rho g. So rho equal to omega by g. Here just now we find out omega equal to 7000 Newton per meter cube. G is 9.81. So 713.5 kg per meter cube. Next we specific gravity, density of the liquid divided by density of the water. So density of the liquid, just now we find out 713.5 divided by 1000 is density of water. That we find specific gravity S equal to 0.7135. So it has no unit. Next we are going to see problem 1.2. Calculate the density, that is mass density, specific weight and weight of 1 liter of petrol having specific gravity 0.7. Given data, we know volume 1 liter equal to 10 power minus 3 meter cube. They are given specific gravity S equal to 0.7. First we find out density. Here we are going to find out by specific gravity S equal to 0.7. So specific gravity is mass density by mass density of standard liquid, that is water. So density is equal to S specific gravity into 1000 mass density of standard liquid, that is water. So we find out 700 kilogram per meter cube as density. Next we are going to find out specific weight. Specific weight omega equal to rho g. So rho is 700 and g is 9.81. Finally we find out 6867 Newton per meter cube. Next we find out weight W. Specific weight is weight by volume. You find out weight equal to 6.867 Newton.